Action. Hello everyone. Today we are going to solve a Leetcode problem called running sum of 1D array. It's one of the great problem to practice array manipulation and dynamic programming. We will not discuss about dynamic programming, but we will have that concept here. Okay. So let's not get complicated. Here you can see running sum of 1D array. So what the question says? Question says is given the array nums. So we have an array called nums. We define a running sum of an array as running sum of I equal to running sum of 0th to running sum of I, which mean running sum of a element which is at position I is equal to sum of all the elements left to it as well as the sum of the current element. So let's see in one of the example we have 1 2 3 4. Now running sum of 0th element will be array of 0 plus all the elements left to it, which means 0 to I. So here we have only 1. So what is the running sum of second element? So sum of 0th element plus first element, that is 3. Running sum of third element is all the sum from 0th index to the current index, that is 1 2 3, that is 6, and in the similar way it is 10. So this is how a running sum called. So in order to give generalized formula, sorry, generalized formula, running sum of I is equal to num of 0 plus 2 num of I. Okay, so this is num of I. So now this is the approach. Okay, so now what is the how can we implement it? So basically let's say the approach 1. Okay, so we'll discuss about the naive approach, the very basic approach. So now we have an array called nums. Okay, and we need to find the running sum for all the elements, which means we need to what is the return data type? Return data type will be an array. So we are going to write a method which will return the array. So that array will be running sum of 1D array for the given array. Okay, so now let's see how we can do it. Okay, so now let's say we have an array and we have nums array. So now what we are going to do is we will iterate over each element. Okay, over each element. So in the first iteration it will be 1, so sum will be 1. In the second iteration it will be 2, and now what I am going to add, I am going to add 2 plus whatever the element that I got from the previous iteration 1. Okay, which will be 3, because we already know the value of previous element, so we don't have to do 1 plus 2 again. I'll show you in the third iteration. For the third iteration, which is element 3, now I don't want to add 1 plus 2, all those things. Okay, so now what I don't want to add 1 plus 2 plus 3, so what I will do, 3 plus whatever the value I got here. So now in the fourth iteration I will add 4 plus, I don't want to add 1 plus 2 plus 3, because I already know here, right? 3 plus 3 6, so I will add 6, which is 10. So here we are basically memorizing the value that we got from the previous iteration. That's how dynamic programming works. We don't get into deeper here because it's an easy level program. Okay, so now let's see how do we do it via code. Okay, so now let's say via code I have a Java program. So I'll just write whatever is required for int I is equal to 0, I less than nums dot length, then I plus plus. I have started a iteration loop. So here one of the thing is I will so all these numbers, right, all these numbers, okay, so I might need it in the future and I have to keep on incrementing, so I am defining a variable called int count. Okay, so what I can do is I can define it before here. Okay, int count is equal to 0. Okay, so now what I can do is either I can create a new array or I can use the existing array. So if I have to create a new array, then the space complexities will be often, but we have to optimize. That's the purpose of competitive programming. So let's not use a additional space. So here I have nums of I is equal to So obviously the current element will be included in sum. If you see, for 1 we had 1, for 2 we had 2, for 3 we had 3, for 4 we had 4. So which means current element will be included plus sum will be included. What is sum? Sum will be the sum of all the elements next to it. So I have taken count as that sum. Okay, count. So in first iteration count will be 0, right? So nums of I is equal to nums of I, and then I will, what I will do, I will increase that count. So then count will be the the current answer, right? The count will be the current answer. Then count is equal to nums of I. Okay, so yeah, so this is all, that's all. So now let's say in the second iteration nums of 2. Okay, so this is the code. I am just ending the code, so this is just for understanding purpose. Nums of 1 is equal to, what is nums of 1? So I will just start 0. This is I 0 1 2 3. Okay, nums of 1 is equal to, here 2 plus what is count? Count will be 1 is equal to 3. Okay, so now count will be 3. Okay, now nums of 2 is equal to, what is nums of 2? 3 plus 3, which is 6. Now count is 6. Okay, so now here nums of 3. Okay, 3 is equal to, what is nums of 3? 4. 4 plus count 6 is equal to 10. So that's all. Right, so this is how the code is working, and I will erase all this. This is just for temporary. Yeah, so finally this is the code. Okay, and time complexity will be of n, because we'll be iterating with respect to number of elements, and space complexity we are not using any additional space, right? So this is about this problem running sum of 1D array. That's all for this video. Let me know if you found it useful, and if you have any doubts, please drop them in the comment section. Thank you.